In this video, we will solve this tricky exponential equation. Now, to solve this tricky exponential equation, all we need to do is to use some laws of indices and then define a factor of 2048. Now, if we do that, we are simply going to get the solution to this question. Now, let's look at the factors of 2048. We'll have our 2048. What are the factors of 2048? 2 will divide 2048 to give us 10, 2, and what? And 4, right? Good. Now, 2 will also go to give us, this will give us 5, 1, and what? And 2. And then 2 will also simply go to give us 2, 5, and 6. If 2 can still divide this, we are simply going to have 1, 2, and 8. Now let's stop it there. 2 will still continue until we get the minimum value. Now let's consider these factors and see how we'll apply this factor. Now remember a law of indices. If we have our y to the power of y equal to 2 to the power of 2048, we can simply apply a law of indices to simplify this. Now from the law of indices, if we are told that a to the value a to the power of x, y, right, can be equal to a to the power of x multiplied by y, right? So that is taken. So if we apply that here, we are going to find out that the value of y to the power of y can be equal to 2 to the power of 2 multiplied by 10 to 4. Now considering this, what this and this can give us, right? When we have this divided by this, because this multiplied by this can give us this. So applying this law of indices, we will now have our y to the power of y to be equal to 2 to the power of 2, or multiplied by 1, 0, 2, 4. Fine. So that is going to give us y to the power of y to be equal to 4 to the power of 1024. Now let's go back to our factors. If we go back to our factors, you'll find out that 2 multiplied by 512 will give us 10024. So if we apply that here, we are going to have this equation to now give us y to the power of y equal to 4 to the power of 2 multiplied by 512, right? So this will give us y to the power of y to be equal to 4 to the power of 2, or multiplied by 512. Good. So if we do that, we are going to have our result to now be y to the power of y to be equal to 16, because 4 squared is going to give us 16 to the power of 512. Now let's go back to our factors. From our factors, you'll find out that 2 to the power of 2 to the power 2 multiplied by 256 will give us 512. So if we simplify that and bring that here, that means y to the power of y will be equal to 16 multiplied by 2 multiplied by 256, and that will give us 512. So if we simplify that, we are going to have y to the power of y to be equal to 16 squared, according to that law of indices, all to the power of 256. Now come to think about this, our y to the power of y will now be equal to 16 squared is going to give us 256 to the power of 256. Now come to see this, that we have same base and same what? Same power. Now according to the law of indices, if we have x to the power of x to be equal to n to the power of n, then our x will be equal to n as long as n is greater than or equal to 1. So if we apply that to this expression, you'll come to see that y will be equal to 256. So y equal to 256 is the solution that satisfies that tricky exponential equation we are given up there. Now let's test to see if our solution is right. That can be proper. Now let's test. If we test to see if our solution is right, we have y to the power of y to be equal to 2 to the power of 2048. Now if we have that, we have 2 to the power 256 to the power of 256. Is it going to give us 2048? 2 to the power of 2048. Now let's try that out. 2 to the power of 256 can simply give us 2 to the power of 256 will give us 2 to the power of 8 will give us 256. So that will be multiplied by 256, and this simply will give us 2 to the power of 8 multiplied by 256, and 8 multiplied by 256 will be equal to 2 to the power of 2048. So we see the value of y, which is equal to 256, simply satisfies that exponential equation, which is a tricky one we have up there. Please don't forget to like, share this video with your friends and colleagues, and remember to subscribe to my channel for more mathematics solutions. Thanks so much for watching, and bye bye for now.